Hello, this is Mr. Steffen, and today in For Your Foundations of Technology, we're going to be talking about problem solving. Problem solving is something a skill that you use every day, whether you realize it or not. When you get up in the morning to brush your teeth, if you brush your teeth, and there's no toothpaste there, then you have to figure out, how am I going to get more toothpaste? Am I going to get some from another bathroom? Am I going to go to the store? That's problem solving. So uh, we we are all naturally problem solvers. However, in the technology world, problem solving can be a little more complex, and so we're going to take you through the steps about how to deal with problems in the technological world. Um, in the picture here, you have a car in a tree. Somebody decided to park their car in the tree. Don't ask me why. However, this is a problem because if this person wants to drive their car to work or to school, they're not going to be able to do it. And so our definition of problem solving is something that is used to satisfy people's technological needs and wants. And so this person probably needs and wants to drive their car to work or school or wherever they're going. And so they need to solve the problem. How are they going to get out of the car? And then probably how are they going to fix the car? But this is the problem. And so we have two areas we're going to talk about. First, one is that problems need to be solved. And the second is that there's opportunities for improvement within technology. And these are two different concepts because not everything needs to be reinvented or solved. Sometimes it's just made better. That doesn't mean a problem is necessarily solved. And so for technological problems, we're going to say that you need to develop tools, machines, or systems to solve these problems. That's how we're going to define what a technological problem is. And that's what we're going to deal with a lot in the classroom. Just like these cans trying to communicate through a little wire that's really slow. That's a problem. So somebody invented this, one of the very first telephones. That's a tool, machine, and a system that is used to solve the problem of communicating over distances. Now, opportunities for improvement. These are technological opportunities that don't necessarily mean that you're solving a problem. However, you are improving upon something. Like I said, you're not necessarily solving a problem. Take this. This is a welder. The guy is using, looks like a wire welder. They've been around a while. If we look at the welder itself, the welding machine, and then we look at this in the picture of these welding robots, the welder that this man is using and the welder machine on the robots are almost identical in function. So the welder itself there was no problem with the welder. It was just improved upon so that it could weld faster, or that it was attached to machines so it could weld more cars at one time. And an example in your book is the coffee pot, and how the coffee pot, people like the percolator coffee pot. However, somebody invented or came up with the Keurig machine, and so there wasn't really a problem with the old one. It still works, but somebody thought, let's make it faster. And so that's what we're talking about. And so in order to solve a problem in the technology world, it's a little more complex than your running out of toothpaste, because if you look at this car, we can't just take a rope, lasso that car, and then pull it out of the tree. Somebody's going to get hurt. It's somebody might get arrested. The car, I don't know the car will get ruined, and so we have to take steps, appropriate steps, to solve these problems. And like and here somebody had to call somebody to drive this machine. Somebody had to call the government or the police to ask if it was okay to get out of the tree and block the road. There's a lot of steps that need to happen before a problem can be appropriately solved. Just like the welder went from him welding by hand to the robots, there are steps that were taken. And then from the cans to the telephone, there are steps that were taken, even years of working and different people working. It just didn't happen overnight or with the first idea. And so we're going to be talking about 4 steps. And there's some people say there's more, but we simplified it down to 4. The first is identify the problem. Developing solutions, evaluating solutions, and then communicating solutions. And so these are the steps we're going to use to solve technological problems. And as you work through do different things in the lab, you'll have to identify these, and you'll have to recognize how, and you'll probably recognize how you use them already, but be able to be more specific about how these are used. So identify, develop solutions, evaluate solutions, and then communicate solutions. And so within each of these, we can be a little more specific. When you identify the problem, then you have to describe the situation. When you have to describe, such as a car in the tree, you have to be able to describe what exactly is the problem. What are what is keeping this? Why has somebody not solved this before? What is getting the car out of the tree? What is the weather like? What are the regulations for blocking the road? There's all kinds of things that you have to describe. How high is it? How heavy is the car? Things like that. And then gather background information. Has this happened before? What else do I need to know before I just dive into solving a problem? And then establishing criteria and constraints if you can't see constraints. Because there are always regulations and rules that need to be followed. If I am going to launch a rocket into the air, I have to get approval through the National Aviation Board or the Flight Commission to launch it in the air. I just can't launch something in the air because I might hit another plane. So we have to make sure we know our boundaries in developing solutions. It's never a good idea just to use the first solution you come up with, because usually it's not the best. And it's never a great idea to use just your solution. Nobody's ever invented anything great on their own. Everybody's had friends or everybody's had partners working along and beside them. To isolate and refine the best solution, you need to throw out the bad ones, the ones that aren't going to work, you don't think will work. You need to narrow things down. You just can't take everybody's idea. And then sketches and drawings. This is where you need to start drawing out your ideas, recording your ideas, because if you don't ever record information, then you won't ever be able to know how to analyze what you want to do, and nobody will trust you to solve a problem if you can't show them some evidence of how your solution is going to work. And then evaluating solutions, modeling and testing the best solutions. You have to be able to build a model or test many things before you can actually try your solution. Before they went to the moon, they couldn't. Um, they had to build a model to test what the moon rover would do. They had to build a simulation because they couldn't go to the moon. You can't always um, just uh, test your solution in the real environment because sometimes you don't have the real environment. And it's like the best solution out after modeling and testing. You can really start to see what doesn't work. And then compare solutions to economic, technical, productions, and all these different constraints. Because if you don't have enough money to build your model or to solve the problem, you should probably find a different solution. Or if there's nobody that can produce the item you want to use, then you can't use it. So there's some constraints that you have to use. And then communicating the solution. Very often, your problem does not stop at you, and you have to be able to communicate what you want to do to somebody who's going to pay for it, or the person whose car is in the tree. You have to prove to them that you can safely get the car out of the tree. Or if you're going to build a bridge, you have to be able to communicate each step of what you're going to do to build that bridge. And then presenting solutions. That goes back to public speaking and writing. You have to be able to verbally and orally, you have to be able to, written and oral reports, you have to be able to explain to people what you're going to do, because you can't explain it so they can understand it, and nobody's going to trust you with your idea. And so that's the basics of our problem solving. And so we'll go more in depth as the semester goes on. But just start thinking throughout your day how many times you solve a problem. And thank you for listening. Have a good day.